The next speaker that we'll have is Christopher Goes. Christopher is the co-founder of Anoma, and he will be speaking about private bartering in the Anoma protocol.
And even theoretically, I can do this. Awesome. Private bartering in the Anoma protocol. Sweet. So thanks everyone for coming. This is one of the, I think, first public presentations on the Anoma protocol, which I co-founded along with Adrian and Noah, who are here in the audience. Hi, Adrian and Noah, and everyone else at Heliax is working on it. Today, I'm going to focus on providing a brief overview of the motivations. So to Gavin's question about the business case for privacy, I'm afraid the question I'm going to answer here is actually more broad. It's like the existential survival of humanity case for privacy, because I think that's a superset of what business use cases would entail. So we'll see if that convinces you or not. Then I will talk a little bit about what Anoma will enable users to do, both on the chain itself and interacting with the Cosmos network as a whole. Then I'll talk about sort of go through a mid-level overview of the technology we're using to instantiate that, and maybe brainstorm a little bit on different ways we could collaborate, because it does indeed sound like there are a lot of parallel efforts which could fuse or perhaps share code in mutually beneficial ways. So first off, why privacy, and honestly, why blockchains? Like, what are blockchains for? If we look at the world today, we've tried to identify some trends and see what kind of commonalities they present, and then see what kind of, based on that analysis, what kind of mechanism, in particular coordination mechanism, may be helpful in alleviating some of these difficulties. So you could think of this as a business use case, but expanding from beyond what is business to what is coordination as a whole. One dystopia that we see in the world is what we call the governmental and corporate surveillance state. There was a really well-researched, frankly, depressing book called The Age of Surveillance Capitalism by Shoshana Zuboff, which, I mean, if you're feeling like overly optimistic about the state of the world, or you want to be disabused of some perhaps technological optimism, or you just want to read like a Marxist ontological critique of the tech giants, I highly recommend this book. Otherwise, it's like 600 pages of depressing. It can be summarized in the sentence, which is that data has been, in my view, mistakenly considered an asset which can be acquired by companies and then monopolized by companies and used by them to exploit network effects, and in general attempt to metricize and control individual user behavior. Now, this spans the gamut from your credit card company noticing that you're purchasing particular things and then recommending you advertisements, or selling your data from to some other company, which will then change what you see when you go on the internet, all the way to nation states preventing dissidents from freely expressing their opinions or otherwise assembling. The technology which is used to restrict those kinds of behaviors tends to be similar, and in both cases operates under a kind of I would say architectural aegis that has not been designed from the ground up to provide sovereignty and security to users. So I think both from the perspective of blockchains from otherwise, we really need to rethink the basic substrates that we're putting together to build these kinds of collective coordination technologies to address this surveillance state. So that's dystopia 1. Dystopia 2, unipolar control of the global financial backplane, which we see in how nation states, particularly the US, but it varies based on who controls it, can weaponize the financial system and enforce their policies, whether justified or not. Dystopia 3, which I'll touch upon in a few points during this talk, is an inability to solve large-scale coordination problems. So collective action problems, in particular, where some individual defection can lead to collective harm, such as individual pollution harming the environment, or individual misinformation harming the information commons. All of these are examples of collective action problems, which traditionally have been solved by coordination structures like governments that have their advantages and disadvantages, but in particular no longer align with the kinds of real-world economic interdependence that exists. Namely, say Westphalian nation states do not have legislative capacity on their own to unilaterally tax carbon or something like that, which means that this simply turns into a game where companies go to other countries and like export and emit their carbon there, and the international coordination mechanisms, such as they are nowhere near binding enough, such as the Paris Accords, nowhere near binding enough to implement or enforce the kinds of policies or cost internalizations that would be requisite to prevent the externalization of harm. So 3 dystopias. What do we do about those dystopias? Our analytical frame is to think of coordination mechanisms as enabling a kind of individuality at different scales. So if you think of a dichotomy between individual and collective, our hypothesis is this is really a false dichotomy, that it's not like the dichotomy that we should be interested in thinking about, if that makes sense. Because individuality exists at whole different kinds of scales. Your cells have some level of individuality, although we don't think about it very much, because they operate together in this kind of cohesive whole, and you have some notion of willpower over your body as a whole. But that takes place, that kind of exchange of information and coordination takes place at whole different scales. You have coordination between your partner or close friends, you have coordination in a community, coordination in a state, coordination in a kind of virtual environment. Like the Cosmos ecosystem is not a traditional community in the sense that it's not denoted or delineated by geographical distance or by some kind of common shared cultural heritage, except the recent cultural heritage of the past few years. But it's a community delineated by a common interest, by a choice. The boundary is porous, but still one can have an event like this, which is situated within the Cosmos community or interfacing to the Cosmos community. So this is a kind of coordination mechanism at some scale. But the level of efficacy and cohesion of these coordination mechanisms varies drastically. And in particular, my argument here is that it varies drastically in ways which do not align with the kinds of economic interdependence that we should be concerned about or that exist in the real world. So where there is, say, a kind of economic interdependence insofar as someone polluting will affect someone else's air quality, or insofar as someone deforesting the Amazon will affect someone else's rainfall next season, that interdependence relation demarcates a certain community, which I would argue requires a coordination mechanism. And many of our problems today can be traced to an inadequacy of our existing coordination mechanisms to both deal with the appropriate computational dimension of the problems and align with those real relations of economic interdependence. So in particular, we have coordination mechanisms aligned with geographical boundaries, like cities, states, Westphalian nation states, and we have a global coordination mechanism called money. Money works as a coordination mechanism. I'm going to argue that it doesn't work very well, but it is the one we have at the moment. It abstracts value by allowing goods and services to be compared against each other, and it abstracts value in a way which is computationally reductive by reducing the difference between an apple and an orange, which have potentially many differences in quality when you eat them, to a single quantity number. And this is computationally efficient, which means that it's convenient when you're choosing what to have for breakfast, and that it scales in a sense. But that computational efficiency is a double-edged sword, because money transmits information about choices at scale. So when you go to a corner shop and choose to buy something, that choice to buy an apple or an orange, or to buy a particular kind of soft drink instead of another kind of soft drink, transmits information all the way up to the supply chain, and may in fact be contributing to deforestation of the Amazon. If there's some supplier up 20 steps up in the supply chain, who has a choice between some kind of less profitable, but more environmentally friendly process, or more profitable but less environmentally friendly process. So that when you're making a purchase, you are essentially choosing not only what coffee you buy at the corner stop or what fruit you buy, but also the incentives governing all of those companies up the supply chain. Yet you have absolutely no information at all about what impact your choice has. So you may not really be, most of us don't want to contribute to deforestation of the Amazon. Let's at least take that as a simplified assumption for the purposes of this argument. But even given that genuine value alignment between people in our community, broadly speaking, because we don't have access to the impacts of our choices, we have no way to express that value. We can only express the simple choice, the computationally reductive choice, which then transmits incentives that perhaps are contrary or at least misaligned to the incentives that we want to create aligned with our values. So there's a business use case for some better kind of coordination system. How might we design a better kind of coordination system? Perhaps unpopularly, and slightly hypocritically, but not very hypocritically, I am going to argue here that stacking layers of synthetic assets is the wrong thing to do. In particular, I think that we should be aiming for a higher degree of dimensionality at a layer. So there's a layer at which you express some kind of preference. And one layer is to use a currency. So when you use a currency, you buy something or another. But that's like a unidimensional layer. And you can stack unidimensional layers. You can have currencies on top of currencies on top of currencies. But then each currency acquires sort of its own divergence potentially from the underlying thing which you're trying to track. And you can see this, of course, in like DeFi projects, which are stacked tokens on tokens on tokens on tokens. And it's no longer clear what exactly it is they are tracking in the real world. Similarly, with say the subprime mortgage crisis or something, the systems of abstraction which stacked on top of each other diverge from the underlying real world assets at play, in that case, causing a lot of bad things to happen and government bailouts, etc. So instead, I argue that we should take language as a prototype when we're trying to design coordination systems. Language has a much higher degree and arguably sort of an unbounded degree of dimensionality at a particular level. So you can express, say, using recursive grammar in sentences, you can express commitments, not necessarily to value at scale, but you can express commitments that are quite detailed, that include conditionals, etc. So the issue with language is that the enforcement mechanism does not scale. So the enforcement mechanism for language is basically honesty and like group norms. And that works very well when you're in a group of 100 people where everyone knows each other. Then you don't really need a fancy government. You don't even need, you don't need blockchains, frankly. Like blockchains would be useless. You just need everyone to track what each other says, and you hold each other accountable for being honest. That kind of enforcement works at that scale, but it does not scale to a global community or to much larger communities because it's too lossy. Because people forget what people said, the meanings of words change, et cetera, et cetera. That's a summary, but roughly you can think of it like that. So with Anoma, we're building a way to commit in a many-dimensional fashion to value in a way that preserves privacy. Let me then run through, I realize I am not going fast enough. So what is Anoma? Anoma then is a sovereign chain which enables private digital asset agnostic bartering between any number of parties. Anoma connects to the Cosmos network, so it speaks IBC, and anyone will be able to, of course, all of our software is open source. Anyone will be able to interact with Anoma through like the standard Cosmos IBC interfaces. A quick question from Dave: what do Pareto optimal changes to state? Pareto optimal changes to state mean that when, if you consider like all of the users of a system and you consider the state of the system as a whole, a Pareto optimal change to the system state is one which all users are either happier with or at least like equally happy with. So if you have an apple and I have an orange and you want my orange and I want your apple, then changing the state such that you have the orange and I have the apple or whatever, that's a Pareto optimal change, and that generalizes. Cool. So what can you do with Anoma? With Anoma, we've built a way, or are building, I should say, that was too, not quite. We are building a way to transfer and exchange any kind of asset, arbitrarily expressible kinds of commitments in privacy. So I'm going to go through the use cases quickly from simple to complex, and then I'll talk a little bit about the technical stack which enables them. From simple to complex, then starting off with simple. In two-party transfer, you can use Anoma just to send assets privately. As I'll talk about in a later slide, we use a modified version of, we use something called the multi-asset shielded pool, which is an updated version of ECC's original work on the sapling circuit, which supports multiple assets. So you can send any asset, which you could transfer over IBC, for example, privately. Then you could also send an asset in privacy where you need to conduct an exchange, say where the recipient wants to be paid in a different currency than you have. You can conduct an n-party exchange. So we've built a custom trade system on Anoma using something called validity predicates. It's a little bit modeled after a system on Ethereum called Wyvern that allows any n-parties to exchange tokens or non-fungible tokens or any asset they can express as some kind of, can semantically express as some kind of representable unit on the ledger with each other, assuming that the change is agreed upon by all parties. So this doesn't require, in particular, the reason we can get rid of this unidimensional unit of account is that this doesn't require a double coincidence of wants, because we can execute the whole thing atomically. So if Alice holds Bitcoin and wants Tezos, Bob holds ETH and wants Bitcoin, and Charlie holds Tezos and wants ETH, none of those two could pairwise trade. So if you want to solve this kind of coordination problem using money, you need to introduce another token, and then they will all like price their assets in that token. But instead, using Anoma, we can swap their assets atomically with one transaction. And this generalizes to the case of non-fungible assets. So maybe one party holds a CryptoKitty, one party holds a ticket, and one party holds a kombucha subscription, and they have, again, preferences which are not pairwise swappable, but which could be settled in a Pareto-optimal fashion by an end-party swap. Cool, collective commitments. So this is all the way to the more complex use cases that will in particular require kinds of Oracle data to and from the ledger that we don't have yet because it's an orthogonal problem, but hopefully will come in time. So if there are several shoe manufacturers somewhere in the supply chain before you buy sneakers that have a choice of whether or not to incorporate the cost of carbon into their into what they're doing, they could choose, say, a more carbon-friendly supplier for their rubber that charges slightly more, or a less carbon-friendly supplier which charges slightly less. Then in a competitive environment, the one which picks the cheaper supplier will end up outcompeting the one which picks the more environmentally friendly supplier, unless there is some way for consumers down the line to kind of enforce their policies, their actual values, by making commitments to value on these shoe manufacturers. So this is the kind of thing that you can build with a collective commitment. So all of these, say, people who buy shoes can get together and agree in some fashion, and agree in particular in a way that is expressible, digitally expressible on the Anoma ledger, that they will only buy shoes from manufacturers or from any, say, sinker company whose manufacturers all incorporate the cost of carbon into their supply chains. And this kind of collective commitment then changes the negotiating leverage to favor the consumers down the line. Cool, privacy internals. So how are we enabling all of this privacy? For simple multi-asset transfers, transfers, we have what's called the multi-asset shielded pool, as I mentioned earlier. That is an upgraded sapling circuit. So thanks to ECC in particular for that original work, which we've updated, so that in the multi-asset shielded pool, not only sender, recipient, and amount, but also denomination are shielded. And all assets on Anoma can use the same multi-asset shielded pool, so their privacy sets are additive. This is integrated into Anoma as a validity predicate, so it's integrated into our trade system and fully integrated with IBC assets. So assets can be transferred in and out over IBC and shielded, and all assets share the anonymity set. We're also doing some research into ways to transfer assets over IBC while they remain shielded. Expect more on that soon. I think there may even be, the presentation later may already talk about that, which is awesome. So potentially some collaboration possibilities there. Cool. Then the final thing to talk about quickly here is that we're also building systems for private liquidity, gossip, and trade. So in order to figure out that, in fact, you have three people who are interested in trading with each other, one who holds a kombucha subscription, one a ticket, and one a CryptoKitty, you need a way to discover. And we want to build a kind of discovery that doesn't assume any kind of prior knowledge. So we're working on the liquidity gossip layer, in which we also want to preserve the kinds of privacy which it's possible to preserve. Now, this is a tricky problem because there are trade-offs between privacy and spam prevention. So in order to address this, we're working on ways for nodes to create proofs, little proofs, sometimes they're knowledge, sometimes somewhat simpler, about the liquidity that they're gossiping, which they'll send along with the liquidity so that parts of the information itself can remain private. And we're trying to, as much as we can, we can't really do this in full generality without like WebAssembly and Circuit, which is a research project, but we're trying to retain the generality of the trade system alongside these privacy features. So trades can be partially private. Some of the assets may be partially shielded. We'll gradually move towards full privacy over time and already start with full privacy for transfers and including non-fungible tokens, transfers of fungible and non-fungible tokens. All right, I think I probably have ran straight through my question time with that monologue, but if there are any questions, please feel free to write them in the chat or contact me. I would be thrilled to chat. Thanks all.
Yeah, thank you very much, Christopher.